Hello, my name is Ken Harrison. I'm the President and CEO here at GNB Corporation. Today I want to talk about surface finishes inside of a vacuum chamber. The surface finish you put inside of a vacuum chamber can affect the cost a lot. In fact, it can double the material cost in a vacuum chamber. It also affects the lead time. So there are various misconceptions and ideas about the surface finish of a vacuum chamber, and I want to clarify that a little bit. First of all, there are really three reasons to improve the surface finish of a vacuum chamber. One is just for the aesthetics. You want the vacuum chamber to look nice and to be pretty. You can improve the surface finish. Number two is for cleanliness. If you're trying to clean the vacuum chamber and scrub it down and make sure that it's clean, the surface finish can affect how easily that is done. And finally, the pump down speed. The surface finish of a vacuum chamber does affect the pump down speed, and let me explain that. One of the most difficult gases inside of a vacuum chamber to pump is water molecules. It's the moisture and the humidity from the air that becomes attached. Moisture is sticky. It likes to attach to cold surfaces, and the cold surfaces of the vacuum chamber are an ideal surface for the moisture to attach to. And it gets into all the little crevices and hides, and it's hard to get that moisture to leave, and that moisture is part of the gas load inside the vacuum chamber. Sometimes people think in order to get to ultra high vacuum and high vacuum, you have to have a beautiful surface finish on your vacuum chamber. That's not really true. It really is about pump down time instead of ultimate pressure. In other words, if you're exposing the inside of the vacuum chamber to the atmospheric moisture time and time again, you want a very good clean surface finish because you want the moisture to leave the surface of the vacuum chamber very quickly. If you have a long test and it lasts for 2 years and your chamber is going to be under vacuum for a very long period of time, then the pump down speed is not nearly as important. So it depends on the process. There are a variety of surface finishes you can use inside of a vacuum chamber. When we get the plate from the steel mill, it has kind of a rough surface finish on it in most cases. We call that a mill finish. It's because that's what it came from when it came from the steel mill. That can be a good surface finish, but it does not allow the moisture to leave as quickly because it's a little bit rough. Another common surface finish is a 2B surface finish. This is for thinner plate that comes and then the steel mill has rolled it between polished rollers. And so it becomes bright and shiny and reflective, and it's a good surface for a vacuum chamber. For thicker plates, often we improve the surface finish some way. The least expensive method is just bead blasting. You go in with glass beads and you clean the surface and you take off all of the scale that's left behind from the steel mill. This is also a rather quick and simple way to improve the surface finish, and it is very common, used in a variety of vacuum chamber applications. Sometimes though, for cleanliness reasons, you want a smoother surface than what you achieve with the glass bead blasting. And in that case, most customers go to a number 4 grain finish. Number 4 grain finish is uniformly sanded in one direction. You use a 150 grit sandpaper or finer, and you sand it so that it looks really nice and smooth, and that's a good vacuum surface finish. The pump down times as you go through the various surface finishes does improve. Mill scale is the worst, and if you do anything to the mill scale just to even brush it and brighten it up, it gets quite a bit better. Then if you bead blast it, it is significantly better. If you grain it, it's a little bit better. And if you take that one step further, after the graining operation is done, you electropolish it, it gets better yet. Electropolishing is an electrochemical reaction where the surface roughness is taken down a little bit. For example, it typically cuts the surface finish number in about half. So electropolishing will typically cut the surface finish reading in about half. So if you had a 124 finish, it'll cut it down to about a 63 finish in most cases. All of this discussion about surface finishes can be a little bit complicated. At GNB, we want you to have the best value. We want the chamber to meet your needs, we want it to meet the pump down times that you are specifying, and also be cost effective for what you're trying to do. If you have any questions, please contact GNB. We're happy to help you with all of your vacuum hardware needs.